Today in Cabechi's Corner, we're going to look at ratios. A ratio is a comparison of two numbers by division. For the first example, we have 6 to 18, and then we write that as a fraction. The first number is going to be our numerator, and the second number is going to be our denominator. So we have 6 over 18 in fraction form, and again, in the end, we're always trying to simplify, so we have 1/3. In number 2, we have 30 to 24. Again, 30 is my numerator, 24 is my denominator, and I simplify that to 5 over 4. Now, one thing that's important about this, when we're looking at ratios, we're comparing two numbers. So we want to leave this as an improper fraction. We do not want to put this as a mixed number because then you wouldn't be comparing two numbers. Now we're going to use some geometry in with our algebra. So we're going to find the ratios using this four-sided figure. So we have AD is to BC, so that will be our first ratio. So AD has a measurement of 10x, and BC has a measurement of 8, so we'll simplify that. 10 over 8, that simplifies to 5 over 4, and then we have x, our numerator, so that will be our final answer there. And number 2, when we're looking at our measure of angle A, is to measure of angle D. So A is 50 degrees, and D is 130 degrees, and when we simplify that, we'll get 5 over 13. In our last example, we have measure of angle D to the measure of angle C. Now, I know the measure of angle D is 130, and I'm not sure about the measure of angle C. I have to figure out, it's a four-sided figure, it's a quadrilateral, so I know that the interior angles are going to add up to 360. So when I figure out my angle measurements, I know that C is going to be 90. So my denominator will be 90, so when I simplify this, I get 13 over 9 as my final ratio. In looking at number 1, it says the measures of three angles of a triangle are in the ratio 2 to 2 to 5. Find the measure of each angle. Well, we need to realize that the sum of the angles of a triangle are 180, so that's certainly going to help us. And we don't know the measurements. We just know that they're in this ratio, so we're going to use that piece of information. So we're going to say 2x plus 2x plus 5x is equal to 180. We'll combine our like terms. That gives us 9x is equal to 180, and x is equal to 20. Now, in this problem, it doesn't ask us what the value of x is. We want to know the measure of each angle. So I'll substitute that back into my part of my ratio. So 2 times 2 gives me 40, and then I get 40 again. And then my last angle is going to be 5 times 20, which is 100. So there's my three angles, 40, 40, and 100, and they add up to 180, so it looks like I did that one correctly. In number 2, it says the ratio of two complementary angles is 1 to 2. Find the measure of each angle. Well, we have to remember that the word complementary means that when I add them up, I get 90. So again, I'm going to use this ratio. My unknown, again, is going to be x. So I have 1x, or x, plus 2x is equal to 90. So that gives me 3x is equal to 90, or x is equal to 30. I'll use that back into my ratio, and one of my x's is 30. 2 times 30 is 60. So there's the measure of my two angles. When I add them together, it gives me 90. In number 3, it says the measures of the angles of a quadrilateral are in the ratio 7 to 8 to 9 to 12. Find the measure of each angle. Well, we know that a quadrilateral is a four-sided figures, and these four angles are going to add up to 360. So I'll use the same idea. I have 7x plus 8x plus 9x plus 12x is equal to 360. I combine my like terms, and I have 36x is equal to 360, so I divide both sides by 36, and I have x is equal to 10. I substitute that into my ratio, and I have my angle measurements are 70, 80, 90, and 120, and when I add those measurements together, I will get 360, so I know I did it correctly. Now we're going to continue practicing writing ratios in simplest form. So in number 1, if I'm looking at my coefficients, I have 5 over 10, which simplifies to 1 over 2. And then my a's are the same if I look at my variables. So they're going to simplify, and I'm left with b at the bottom. So my simplified answer there is 1 over 2b. In number 2, my coefficients 3 over 4. They don't simplify, so they're going to stay. I only have 1b, so that's going to stay at the top. When I look at my c's, I have 2 c's on the top and 3 c's on the bottom. So I'm going to simplify that, and I'm left with 1 c at the bottom. In number 3, I have 7 times the quantity of x plus 1 over 14 times the quantity of x plus 1. Now my x plus 1's, my binomials, are exactly the same, so I'm allowed to simplify then. And 7 over 14 simplifies to 1 over 2. And the last problem, number 4. Again, I have 7 over 14, which is a monomial, so that's going to simplify to 1 over 2. This time my binomials are not exactly the same, so I cannot simplify them. So I'm just have to leave them as is. So my final answer is x plus 2 over 2 times the quantity of x plus 1. In number 5, I have 5 kilometers over 25 kilometers. Now my units are the same, so they'll simplify. And I'll take 5 over 25 and I'll simplify that to 1/5. So 1/5 is my final answer. In number 6, I have a decimal within my fraction. We don't really like that because decimals and fractions really are the same thing. So I'm going to multiply top and bottom by 10, which will make it a little easier for me. I have 10 over 6. And again, my meters, my units will simplify, so that simplifies to 5 over 3. Now my last one, number 7, I have 1 meter over 85 centimeters. Now they're not the same unit, so we need to fix that first. Now I know that 1 meter is the same as 100 centimeters. So I'm going to make that change first. So that becomes 100 centimeters in my numerator. My centimeters unit will simplify there, so I'm left with 100 over 85. And in simplified form, that becomes 20 over 17. So that's my final answer right there in the most simplified form.